Hello, and welcome to this video introduction to the University of Plymouth's Computing and Software Development degree. In it, I'll take you through some of the key features of how the degree works, talk about what you'll learn, and tell you why you should study this degree at Plymouth. My name is David Walker, and I'm a lecturer in computer science at Plymouth. I'm also the Programmes Manager, which means I'm responsible for ensuring that all of our computing degrees, including this one, are running smoothly. I teach a range of topics that are based around my specialisms in artificial intelligence, web technology, and software development. In the second year, I lead a module that will expose you to ideas and concepts relating to AI. Then in the final year, I run a module in which you'll study full stack web development. I'll talk a little more about those later. Let's start with an overview of the program. Like all of our courses, our computing and software development course is structured into 4 years. I'll talk in more detail about each stage in the coming slides, but for now, here's an overview. Stage 1 is intended for you to get up to speed. We don't require any prior knowledge of computing or programming, so this year is really to get all of our incoming students upskilled to the same level. Once you've got a bedrock of computing knowledge, we start to apply depth to your studies and delve deeper into some of the exciting and topical subjects within the field. At this point, you'll also do a team project, which will develop the co-working skills that are vital to a career in the computing industry. It's important to note that the first year and the first half of the second year are shared between all of our computing degrees. Once you get to the halfway point, you specialise and only study modules on computing and software development topics. This builds in a degree of flexibility, so that if you decide you would like to tailor your studies towards one of the other degree courses, then changing is easy and you won't have missed any content. All of the shared modules include degree-specific content, so you continue to specialise on your chosen degree in those early stages. Stage 3 is an optional placement year. This isn't something you have to do. It's fine to do 3 years of studying, then graduate, but we strongly recommend students undertake a placement. Working in industry for a year has a range of positive effects on both your studies and employability. In the final stage, we continue your in-depth exploration of computing and software development topics, providing you with a wide base of expertise to allow you to operate professionally in the computing industry. You also undertake a substantial individual project. Let's look at each stage in more detail. Each year is split into 2 semesters. Each semester contains 2 modules, and we run a project module across the year at each stage. Semester 1 begins with a module on software engineering in which we teach you to program. As I've already said, no prior programming knowledge is expected or required. We teach you from the ground up and have a strong record of turning out excellent programmers. That said, if you have programming experience, then you can expect to be stretched. This module is designed to cater for both crowds. Computer systems teaches you about how computers work at the operating system and machine level, and you'll learn about computer architectures. All of this is vital if you're going to work in computing. In semester 2, you study cybersecurity and networks. The world is becoming more and more interconnected, and so this understanding of the underlying technology that enables this and ensuring that while doing so users and their data are safe is a really important aspect of your degree. All computing technology is built upon algorithms, data structures, and mathematics, and you gain some exposure to this in semester 2. You'll learn about algorithmic design, efficient data structures, and how to use them within your daily work. Across the 2 semesters in the first year is the computing practice module. This module is an all-year project and is designed to draw upon all of the knowledge you've acquired throughout the year, as well as providing skills in other areas. Following industry-used software lifecycle models, you will produce a substantial computing project within your first year, an early demonstration piece for your portfolio. Stage 2 picks up where Stage 1 leaves off, and begins with an advanced software engineering module. If the first year taught you how to code, this module will teach you how to code well, learning about principles of software development and how to build software to a commercial standard. Software is usually nothing without its data, so we'll also provide an in-depth study of databases in information management and retrieval. You'll learn how to construct a database, get data in and out of it, and use an API to incorporate the data into a program. In semester 2, you'll learn about artificial intelligence. AI is currently taking the world by storm, and if you're interested in a technical career or the societal impact of computing, this module will be of interest. You'll learn about some machine learning techniques, how to optimize something using AI, and knowledge representation. A vital part of any software development process is testing, as at some point someone will ask you if your software actually works. Software development tools and practices will give you an in-depth understanding of how this is done commercially, so that you can give your clients a confident yes to their question. Across semester 2, you undertake a group project. This involves the construction of a substantial piece of software in which you work in a team to achieve. The aim of this project is again to draw together your skills in a holistic way, but also to give those students going on placement exposure to how they will be working. Some students worry about the idea of group work, but it's always impressive to see how well the groups come together and to watch the students realise that everyone can provide a useful contribution to a team. As I've said, the placement year is optional, but we strongly recommend it. Students work in an IT role within a company, gaining valuable experience of what their future career might be like, and most importantly, it's paid. While it's up to the student to find a placement, the university provides support in both finding and obtaining the position. While you're on placement, you'll have visits from a placement tutor, one of the lecturers from the computing subject group. We come along and make sure that everything's going as it should and that your education is being supported so that you gain valuable experience. Doing a placement can have an extremely positive effect on your studies and career prospects. You come back from the placement to complete your final year having learned to work. We often find placement students stick to office hours when they return, spending a day working in the lab or working on their coursework or final year project. Our statistics show that the result can be an uplift in degree classification, so you really can reap the benefits of doing a placement very quickly. Your career prospects are also improved. You've demonstrated that you can hold down a job within the industry you're looking for employment in. This tells potential employers that you can work and makes you less of a risk for them to appoint. You may even find that your placement company wants you back. We've had many students in the past come back with job offers for when they graduate, as well as offers of financial support for their final year and final year project ideas. It really is a valuable opportunity that I hope you'll consider. The final year gives opportunities to study the topics that will prepare you for work, which you may well be doing within a few months of studying these modules, all being well. Semester 1 begins with the Software Project Management module, which takes you through the steps of a project and provides tools and techniques that will help you get the best from a software development team. Full stack development looks at the development of software to run on the web, including client, server, and database tiers. As part of this module, you will follow commercial practices to develop a piece of web-based software when you build a self-chosen project. In semester 2, you'll learn about usability. Usability is a vital component of constructing useful computer systems, and you'll learn about the principles of human-computer interaction and data visualization in this module. The final module in semester 2 exposes you to big data. More than just a buzzword, you will learn about how to manage big data and how to use it to provide useful insight for your organization. Alongside these modules is the final year individual project, which runs for the whole year. Here you work on a substantial computing project that draws together everything you've learned during your time with us. You will use computing to solve a problem, and that problem and the way in which you tackle it is up to you to define. You'll be assigned a project supervisor who will ensure that over the course of the year you produce a piece of work that really showcases your skills. Students often say that this is the most enjoyable part of their degree, and it's something employers will ask about during interviews. So a good final year project can really help to sell you to a company. At the end of the year, we hold the final year project showcase and invite our industry partners along to see our students work. It's not unusual for job offers to happen at the showcase, so a good project can be a great way of getting a graduate level job. Our degrees are based on a substantial industry base. The courses are developed in discussion with an industry advisory panel featuring some of the big names in computing, such as IBM, Google, and Microsoft. Our curriculum is based on the current state of the computing field, with an eye on where it might go in the coming years as you begin your career. We constantly revise the programs to ensure that they remain on the cutting edge. Our academics have a strong industry background, many having worked in software development and other computing-related roles commercially, as well as being active researchers within the computing field. Our students also work on commercially based projects throughout their degree. The result of this is industry engagement is that we produce students who are quickly useful within a company. Placement companies often seek to attract Plymouth students as they know they'll be a useful addition to their organisation. And this goes to postgraduate employment too, which is reflected in our strong graduate employability rates. So how are you actually taught? What is it like to be a computing and software development student at Plymouth? The programme is intended to reflect a working week, with each of your modules requiring approximately 12 hours work. Some of this time is supported. For example, a 2-hour lecture in which you'll be taught about a theoretical topic, and a 2-hour seminar or workshop each week that will enable you to try out the concepts from the lecture. The remainder of the time is for you to complete set exercises, coursework, engage in group meetings, and to undertake independent study around the topic. All of our work is assessed by coursework and practice. An example of a practice assessment might be a demonstration or presentation. There are no exams because we look to assess you with authentic activities that reflect how you will work within industry. All of our teaching material is available through our digital learning environment, so it can be accessed at any time. Any specialist software or equipment is provided through our dedicated labs. So that is a brief introduction to the Computing and Software degree programme at Plymouth. As I hope I've conveyed, studying this degree will prepare you for a career that can take you anywhere in the computing field. Our graduates go all over the world and make successful careers for themselves based on the strong foundation we've given them here at Plymouth. Thank you for watching, and we hope to see you in Plymouth very soon. If you'd like any further information about applying to this course or one of our other computing degrees, you can contact the university's admissions office at admissions@plymouth.ac.uk. If you'd like any more specific information about the course, you're welcome to email me at david.walker@plymouth.ac.uk.